Let's now look at hypothesis testing for proportions. And we'll do 3 examples. I'll do the first and the second with the traditional method. I'll then redo the second and do the third with the p-test method. For the traditional method, we need our test value, and that's found by p hat minus p over the square root of pq over n. So just a reminder what all these symbols mean. P hat is my sample proportion or percentage. P is going to be my population proportion. Q is 1 minus P, and N is the sample size. And other than this test value, the rest of the test is exactly the same, and we'll use the z-table just like confidence intervals for proportions did. So let's jump right into examples. Let's suppose that a researcher is claiming that 17% of young people under the age of 18 are obese. We want to test this claim. So let's suppose we select 200 people in that age group. Within those 200, we found that 42 were obese. And suppose we want to test this claim at alpha equal to 0.05. Let's start with our hypotheses. We're assuming that the actual percentage is 17%, and all we want to do is test if this is right, so not equal to 0.17. So we need to find our critical values for a two-tailed test. Since alpha is equal to 0.05, each one of these areas is going to be 0.025, so that total it's an area of 0.05. And so now we need to go to our z-table. So here's our z-table, and we need to find 0.025 in the center of the table. So if we look through, we actually can find exactly 0.025 here, and that corresponds to negative 1.96. Going back to our problem, that means our critical values are negative 1.96 and positive 1.96. We also need to know the value of p hat, which is going to be the 42 out of 200, which is 0.21. So now let's find our test value. It said p hat, which is 0.21, minus p, 0.17, over the square root of p, which is 0.17, q, which is 1 minus 0.17, or 0.83, divided by the sample size, 200. And when we work that out, we get roughly 1.51. If we go back to our table, 1.51 is somewhere in here. And so we cannot reject. So the actual question was, is there enough evidence to say that this claim is incorrect? And the answer is no, there's not enough evidence to say that the original claim is wrong. Let's look at another example. Let's suppose that we have a survey that states that 23% of gun owners are women. We have a particular person that thinks where they live, the percentage is actually smaller than this. In order to test this claim, he randomly selects 100 women and finds that 11% of them are gun owners. And he wants to test this claim at alpha equal to 0.01. So my hypotheses are that it's either equal to 0.23 or, in this case, less than 0.23. So we have a left-tailed test, and we have alpha equal to 0.01. So now let's go to the z-table. We need to find 0.01 in the center of this table, and the closest we can get is this 0.0099, which is negative 2.33. Next, we want to find our critical value, or our test value, sorry, which said p hat, which in this case is 11, minus P, 0.23, over the square root of P times Q, which will be 1 minus P, over N, which gives me negative 2.85. And if I look back at my picture, negative 2.85 is definitely in this reject region, so we're going to say that we reject H0, so it actually is lower. And this was the traditional method. What if I wanted to do this problem with the p-value method? Well, my hypotheses would remain the same, and my critical values would remain the same. But now we're going to actually look up our critical value in our table, negative 2.85, or our test value in the table, negative 2.85. Coming to our table, down to negative 2.8, and then over to 5, gives me 0.0021. Looking back at the problem, if our p-value is 0.0021, that's definitely less than our alpha of 0.01, so once again, we would reject H0. Let's do one more using the p-value method. So let's suppose that an attorney claims that over 25% of all lawyers advertise. In order to test this, we have a random sample of 200 lawyers and found that 63 of them advertised. And we want to test the claim at alpha equal to 0.05. So either the percentage is 0.25 or it's bigger than 0.25. For our p-value method, we're going to jump straight to the test value. In order for the test value, we need p hat, which is going to be 63 over 200, which is 0.315. So my test value is p hat, 0.315, minus p, 0.25, over the square root of p, times q, which is 1 minus p, or 0.75, over n, my sample size. And that gives me a value of roughly 2.12. And now I need to look that value up in my z-table. Looking at my z-table, we go down to 2.1 and over to 2 to get 0.9830. Now, this isn't my p-value because this was a right-tailed test. I actually need to do 1 minus 0.9830 to get my actual p-value of 0.017, which is smaller than my alpha value, which means we do reject H0. So H0 was false. My alternative hypothesis is true, so yes, this person was right. Over 25% of these lawyers advertise.